Hello guys, this is Redox here again. We're going to be trying something different now. We're going to be doing a math lesson on Riemann sums. Riemann sum is essentially what this symbol is in math, right? It's the sigma notation, and it's typically used like this, and then when you write this down, it's going to be like this symbol, and then down here there's going to be a variable, usually I, which is going to be equal to a value. Let's say like it's usually a small number, so it's going to be 1. We're going to put here, and then the number up here, it's either going to be a variable like n, or it's going to be something like a actual number like 1, but it has to be higher than 1, so we're going to do like 5. So basically what this is saying is, well, first let me go over what a Riemann sum actually does. So basically it takes this number that's given in the starting value, and it's like a loop where it goes all the way up to 5, and it finds all the sums where I is going towards 5. So if we do 2, we have to, if we say we want to find the sum of the Riemann sum of 2 when I equals 1 to 5, we essentially say that we want to find the sum of 2 essentially about 5 times, because we're ending at 5 and we're starting at 1. So when we want to find the sum of 2, we do 2 plus, so this is when I is 1, then 2 when I is 2, 2 when I is 3, 2 when I is 4, and lastly 2 when I is 5. Now essentially this is 2, 4, 6, 8, 10, so this would essentially just be 10, right? It's just finding the sum of all the values inside of the Riemann sum, so typically on the right of the sigma notation, and it's finding it when I is equal to 1 all the way to when it's equal to 5. So let's do a practice problem, okay? Let me just erase this. Just erase this. Let's increase it, actually. Okay. So, let's do a practice problem. Let's say it's going to be I is equal to 1 all the way to 6, and we want to find the value of a constant. A constant is basically just one number, right? So we're just going to say 5. So a constant is just a number. So we want to find the summation of a 5 when I equals 1 to 6. And so essentially we want to add 5 6 times. So we do 5 plus 5 when I equals 1. This is when I equals 1. This is when I equals 2. And so on. It's just going to keep on repeating. This is when I equals 3. This is when I equals 4. This is when I equals 5. And lastly, this is when I equals 6. It's going to be 5, 10, 15, 20, 25, 30, which is just 5 times 6, which is 30. Basically, a shortcut to doing all this is by multiplying this top number by this number this constant that we're trying to find the Riemann sum of. So if we want to just do a shortcut method, which you probably already knew, we do 6 times 5, because this is from the top of the Riemann sum, or the sigma notation, and this is what the value to the right is, the constant. Let's look at a different problem now. Let's say we are given when I equals 1 to 4 Riemann sum. Looks pretty normal right now, right? What if we do that? Now, looks a lot different, right? So basically, this isn't a constant anymore. This is a constantly changing variable, as seen here, because every time a Riemann sum occurs, I is getting increased by 1. So for the first one, I equals 1. This is the first iteration, so it's just going to be 1. Okay, so this is when I is equal to 1. It's just going to be 1. Now, normally, if it was a constant, we would just constantly add 1 4 times. So 4 times 1 is 4. But that's if this was 1 or a constant, but it's actually I, which is what's shown right here. So it means that it's a constantly changing variable. So when I is equal to 2, this would essentially just be 2, because the I is being iterated as I equals 2 because it's being added, because the first initial I values is being added to 1, so it would be 2. Now, and you just plug this right into here, and now we want to do this 4 times, so I equals 3. Guess what it would be? Yeah, you're right, 3. And lastly, because it's to the last value of 4 right here, we want to do I equals 4. And this would just be 4. Now we want to add all these all together. It would be 3 plus 3, 6 plus 4 equals 10. Interesting, right? But what if I told you there's another shortcut to this solution? So basically the solution to this problem, or a solution to make this faster, or a formula you could use, is essentially just n, well, this is the correct notation, n times n plus 1 all over 2. This is the formula for something when it's just I, or something multiplied by I. No powers or exponents or anything. You might be wondering, what is n? But as covered previously in the video, n is basically just this number at the top of the Riemann sum. So it usually starts at I equals 1, and then this value right here is n, right here. So in this case, n is 4. So we plug in n right here, which is 4, and then right here, n plus 1 is 4 plus 1, which is 5, and then all divided by 2. So 4 times 5 divided by 2 is equal to 10. Huh, funny how that turns out, right? Because this is 20, and then divided by 2 is just this. Now, funny how it turns out, right? Because this is the same as this, but way quicker, am I right? Now, let us do a practice problem. Alright. Equals 1, let's say 5. That's a nice number. Now let's do I. What would this be? You can pause the video. Alright, let's start. Alright, so we're going to use the formula for this so it's quicker. Reminder is n times n plus 1 divided by 2. Let's plug in the values. N is 5. 5. N plus 1 is 6. Over 2 is 15. So it's 5 times 6 divided by 2 equals what? Cancel it out. 5 times 3, 5 times 3, sorry. 5 times 3, 15. That's our final answer. Alright. Now, let's try something different once again. Alright. Might be thinking, yeah, we're doing fine. Now let's add. Oh, don't like that at all, am I right? What the? Oopsies. Alright, now let's try something a little bit more different. I equals 1, let's say 3. Now, what if we add a coefficient? You might be wondering, now, redox, how might we attempt this? Well, it's essentially almost the same process, but okay, let's first do it like in the slow method, alright? So coefficient I equals 1, we want to do 2. This is when I equals 1, because when I equals 1, you multiply that by 2, and it's just going to be 2. Now, when I equals 2, it's going to be 4, because 2 times 2 is 4. Now, lastly, we do I equals 3. This is going to be 3 times 2, which is 6. Now, let's add all these values up. It is 12. Now, you might be thinking, now, how might we do this in the shortcut method? Well, there's multiple ways we could actually attempt this in the shortcut method. So first off, let me erase some of this actually. So, you might be wondering, how might we do this in shortcut? Well, you could obviously just, or actually I haven't taught this yet, but you can take out the 2, alright? You can take it out of the Riemann sum. And now you're just left with I, and now you can just do the formula n times n plus 1 divided by 2. This would just be 3 times 3 plus 1, which is 4. 12 divided by 2 is just 6. Now, this is just I. So now, we plug this back in for this, because this is what 6 is. Now, we have 2 times 6, which is equal to 12. Same as that. Now, you could just skip all of that and essentially, oops, got rid of that as well. Well, essentially, if you really want to do this even quicker, you could, instead of just taking it out of the Riemann sum, you could just apply it to the formula, to n plus 1 divided by 2. And you could just multiply the coefficient by the formula, which is this portion. But since these two cancel out, it's just n times n plus 1, which is 3 times 4, which is equal to 12. Okay, now let's go over another part of this. Now, I'm just going to leave part of this. I'm going to leave a little bit of this, alright? So, we're going to leave this. We're going to leave this equation, alright? What if we add a power? What if we add I squared? Now, if we do this normally, I equals 1. When I equals 1, I squared is just 1. When I equals 2, I squared is 4. When I equals 3, I squared is 9. Now we just add these up. 1 plus 4 is 5, plus 9 is just 14. Oops, it's just 14, right? Now, how about we look at a shortcut? We love shortcuts, don't we? Now, what's unfortunate is that, what's a little bit unfortunate, not really that unfortunate, is that it's a little bit longer, but it's really similar to the previous one that we've done already. Alright, this new formula. Now, remember what the original one was? It's n times n plus 1 divided by 2. Now, for I squared specifically, there's a new formula. It is n times n plus 1. Now, this was the original numerator. Now, we just do 2n plus 1. And we divide it all by 6 instead of 2. This is the new formula for I squared. Alright, now let's apply this. Now, n is equal to 3, so we plug that in right there. So 3 times n plus 1 is 3 for n is plus 1 is just 4, and then 2n plus 1, 2 times 6, or 2 times 3 equals 6, plus 1 is 7. and then we divide all this by 6. So it's 12 times 7 divided by 6. Cancel it out. 2 times 7 equals 14. Funny how that turns out, am I right? Now, let's do one final concept before I end this video. Unfortunately, we will not be able to get to the looking at under the graph, but we will eventually get there later in the next video. Looking at the area under the graph. But now let's go over one last formula that I'd like for you guys to know. Now, what if we do this? I equals 1. Let's do 4. What if we do I cubed? Interesting, right? Well, so let's just do this normally. Plug in 1 for I, it's just 1, plus 2 for I, which is 8, which is 2 cubed, 3 for I, 27, 3 cubed, finally 4 for I, 64, 4 cubed. Now, let's add it all up. 64 plus 27 is 91. Plus 8 is 99, plus 1 is 100. That's a pretty nice number, 100. Which means this sum is equal to 100. Now, let's get to the shortcut. Alright, now, let us see what the formula is. So, originally, the old formula for just I is n plus 1 over 2. This is for I, not for I cubed, alright? Now, how will we get rid of this formula? Let's make a new one. I cubed. Now, look at this formula. It's n times n plus 1 over 2. What if we just square that entire thing, right? Well, what if we just square that entire thing? Well, that's essentially what I cubed is. It's n squared times n plus 1 squared over 4, which is the formula for I cubed. Alright, this one right here. Now, let's solve it using this formula. So, n is equal to 4, n squared is 16 times 4 plus 1 whole squared is 5 squared, which is 25 over 4. Now let's get rid of that. 4 times 25 is equal to 100. Is equal to this right here. Now, I'm going to leave you guys with a couple of practice problems, alright? I want you guys to just text them in the comments and tell me what you think they are. And comment any other comments you would like to give for my teaching, if you like it, if you don't. Anything will be appreciated. This is just a challenge problem. You guys obviously don't have to do it. But it will be some fun practice, you know? Alright, thank you guys for watching. Appreciate it. Please like and subscribe, and share this video with all your friends who might need help with some calculus Riemann sums. I'll get back to you guys on the other parts of the Riemann sum next video. Bye.